Okay, may I start? Gautam, may I start or wait? Am I audible?
Yes.
Yes, sir.
Okay. Yeah, I'm asking Dr. Gautam Bhattacharya, may I start or should I wait for a few moments?
I
Dr.
think you
Datta, are
should
you
wait
ready?
because I am ready,
I'm
but
fine.
as per schedule, it was 7:30.
Yes, 7:30. Yeah,
So we can start at 7:30.
exactly. Okay. Thank you. Everyone should mute. I request everyone to mute yourself. No sound should come, please.
I think sound is coming from Krishna Kumar.
I'm not the admin at this moment.
Hmm.
Okay.
Krishna Kumar, mute yourself.
Krishna Kumar, can you hear us? Please mute yourself. Okay. So I think it's perfectly 7:30 now. So I begin. Good afternoon, everyone, and we will be starting this online session today. There will be one lecture today. Tomorrow there will be one more lecture, and day after tomorrow we will be having two different lectures. And this may not be the end because after that we may arrange some more. But in between, we're having these four lectures in these 3 days. So I pay your just a very feeble attention there because you need to attentively listen to Dr. Dipankar Datta. He will be actually saying something about the very burning issues nowadays. This is all about artificial intelligence, machine learning, and data science. So his topic will be today Introduction to Artificial Intelligence, Machine Learning, and Data Science. Before to start, I have to introduce, this is my formality and this is my kind privilege to have this opportunity to just introduce before you Dr. Dipankar Datta. Presently, he is an associate professor in the Department of Computer Science and Engineering at our institute, University Institute of Technology, the University of Burdwan. And just to say about Dr. Dipankar Datta earned his bachelor's degree in engineering from Jalpaiguri Government Engineering College in the year 1996. And he did his MTech in computer technology from Jadavpur University in the year 2004. In the year 2019, he obtained his PhD in engineering from the Department of Computer Science and Technology at Indian Institute of Engineering Science and Technology, which was previously known as BE College Shibpur. Currently, as I have already mentioned, he is an associate professor in our institute and the Department of CAC. Before entering into the academia, he gained his valuable working experience as an industry expert, including DC Industrial Plant Service Limited and Bright Metalloy Private Limited during the season 1996 to 2004. He is a senior member of IEEE, one of the very premier institute, which is a world recognized institute, publishing different journals as well as different communities are there, different societies are there, you know, and that society is an elite society, and he's a senior member there since 2013. And his research domains are including data mining, artificial intelligence, soft computing, multi-objective genetic algorithm, convolutional neural network, and fuzzy logic. He has around 30 publications in different reputed journals in forms of articles, regular articles, in forms of book chapters, as well as conference proceedings. He served as reviewer in different SCI index journals published by either IEEE or Springer or Elsevier. These are the big houses, publication houses known in the different parts of the globe. Notably, that's to mention here, notably two of his publications published in the Expert Systems and Applications, which is one of the leading journals in artificial intelligence, and having impact factor about 8.5. So he has two publications there. So with this few words, I introduce Dr. Dipankar Dotto, and I request him to start his lecture. And as I've already mentioned, the topic will be here, Introduction to Artificial Intelligence, Machine Learning, and Data Science. Over to you, Dr. Dotto.
Okay, thank you very much, Dr. Ghosh, for your nice introduction. Okay, coming to the lecture, I think all of you are first year students. So I think this may be your first lecture at UIT or not. Means, is it the first lecture or you have
No,
faced
not
other
exactly
lectures?
the first lecture. Some other lectures were already there in the very first
Okay.
day. Might be the
Okay.
fifth lecture. Yeah.
Okay. Those are online or offline?
Online.
Okay. Okay. So on different topics, I think.
Yes, different topics, of course.
Okay. Okay. So this may be the first lecture in the field of computer science or not?
Yes, this is the first lecture in
Okay.
computer science.
Okay. Okay. So I think everybody will accept that nowadays in whatever stream you are going to study, suppose you are going to study in civil engineering or say electronics engineering or any other field, you should have idea about computer science, because in every field of engineering we are now applying different means programming and all this thing, computer science stuff. Okay, and almost in every field nowadays we are using AI and all this thing. Okay, so basic idea about AI is very important in whatever field you are studying. Okay, so today I will discuss basic stuff of AI. I will not discuss any mathematical thing or very complicated thing that will be complicated for you. Okay, so during my lecture, I think I will show different types of videos, okay, to make it more interesting. And this talk will be a popular type of talk. Means I will not discuss anything theoretical or anything very related with, say, study or which are very related with your means theoretical thing that we normally give, means that will normally lecture give, means deliver in our classroom. Okay, so mostly it will be a popular lecture, and during my lecture you can ask any question. Means my lecture should be a means two-way type of thing. Okay. And all of you know Bengali, or some of you don't know Bengali?
Sir, I don't
You can
know Bengali.
Yes, sir. I
so
don't know
one
Bengali.
person. Okay, okay. So
Sir, I also don't know Bengali.
okay, okay. So some students are there who don't know Bengali. So mostly I will talk in English. Okay, and I may use one or two Bengali words, but again I will translate that into English. So I think you will not face any difficulty. Okay, unmute yourself. Sabir Ali, unmute yourself. Okay, fine. So if you want to talk anything, then means unmute yourself. Otherwise, mute yourself. Okay, so mute yourself normally. Okay, so I think my skin is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Definitely,
okay.
sir.
Mute yourself. Mute yourself. Okay, so introduction to AI, ML, and DS. What Kosiks are already told. Okay, so my topic will be introduction to AI. AI means artificial intelligence. ML means machine learning. DS means data science. Okay, so mostly I will discuss on this. Okay, so present species of man is known as Homo sapiens. I think everybody know that. Okay, so what is the meaning of that?
Yes, sir.
So so the meaning of is man the wise. Okay, so it's a Latin word. So the meaning of that word is man the wise. So man with wisdom. Okay, so we have tried to understand how we think. We are trying to understand how human beings are thinking. Okay, so AI is a study how to make computer to think at which at this moment people are doing better. Okay, so artificial intelligence is the study to understand, to make the computer to do thing at which at the moment people are doing better than machine. Okay, so this term was coined by John McCarthy in 1956. He was a scientist at Massachusetts Institute of Technology. I think everybody heard about MIT, Massachusetts Institute of
Yes, sir.
Technology. Okay, so this term, AI term, was first proposed by one person. The person name was John McCarthy, and it is AI is not a new thing. It was first coined in 1956. So I think more than 75 years old. Okay, so what is the definition of AI? AI is concerned with design of intelligence in artificial device. So in this definition, there are two things. One is intelligent, another is artificial device. So I will discuss these two things now. Okay, so two things are there. One is intelligence, another is artificial device. Now I will discuss about intelligence. Different types of intelligence. Okay, see, there are 4 types of intelligence. First one is when a machine is thinking humanly. Okay, thinking like human being. That is one approach of intelligence. We are trying to build a machine which will think like human being. Okay, so human thinking is always correct or not? If I ask you a question that your thought process is always correct or not correct?
Maybe not correct.
Not correct, sir.
No, sir. No,
Not
sir.
correct. So sometimes we are thinking correctly, sometimes we are not thinking correctly. So when we are building a machine by following the thinking process of human being, so the machine will also not think correctly sometimes. That is one approach of artificial intelligence. Then second approach is thinking rationally, means always correct. Okay, so machine will always think in a rational manner, means it will always think correctly, thinking rationally. Then third approach is acting humanly, act like human being. So human action is always correct or not? Human are always doing the right thing or not?
No, sir.
No, no. So if we want to replicate that in machine, so the machine will always not do the correct thing. Okay, so acting humanly, that type of machine we will build by artificial intelligence. Then fourth one is acting rationally. Machine will always do correct thing. Okay, so that is acting rationally. So there are 4 approach of artificial intelligence. Different systems are built by different researcher by the application of AI, but the paradigm are different. 4 paradigms are there. These are 4 paradigms. Okay, so 4 main approaches to artificial intelligence. Okay, now artificial intelligence are some algorithms, some programming, software programs. We are running those programs on some machine. So those machines are hardware, and those machines are known as artificial device. Now we may have smartphone, chatbot, self-driving cars, game-playing AI, robots, language translation app, recommender system, and many more hardwares are there on which we are running different AI algorithms. Okay, so these are artificial device. So see what I have told. I will discuss about intelligence and I will discuss about artificial device. So I told about different types of intelligence. I told about different types of artificial device. Okay, then I will show some example. I think everybody aware of self-driving car, driverless
Yes,
car.
sir.
Yes, sir.
Yes, sir.
So his journey starts at 1989. Okay, at Carnegie Mellon University, CMU. Okay, they developed ALVIANN. Okay, what is the full form? It's a neural network based system. Okay, so see what is the full form? Autonomous land vehicle in a neural network. What they did, they built a car. Okay, initially the car was driven by human being. Now when human being is driving the car, the machine was learning how human being is driving the car. Then after that, the car is driven by the machine. Okay, so in 1989, the system drove a car from east coast of USA to the west coast, a total of 2850 miles. Out of these, about 50 miles was driven by human and rest solely by the system. Okay, now I think all of you likes cinema.
Yes, sir.
Yes, sir.
Okay, so to
Sir.
make the lecture more interesting,
Yes,
I will
sir.
show some videos. Okay, I will show some videos. It's like a cinema. So this is the first video. You can see Google self-driving car. 1 minute. What happened?
Google takes their self-driving cars for a first test drive. Reuters reporting the two-seaters don't have steering wheels, accelerators, or brake pedals. The tech giant releasing this video of users driving Tuesday following a code conference in Southern California. Participants raving about the experience.
There's nothing that makes you feel the least bit friendly. What she really liked was that it slowed down before and around the curve.
The small electric cars are currently just prototypes. Google's been building through partnerships with automotive and suppliers and manufacturers. Google plans to build up to 200 cars in the near future and hopes the vehicle will be available in a couple years. Make sure to check out more Newsbreaker stories on newsbreaker.tv and streaming on iHeartRadio.
Okay, so I think you have seen the video. Okay, nowadays self-driving car is practical, means a lot of companies are now making self-driving car. Tesla is the one of the leading company, and a lot of self-driving car in the road also. Means in USA, a lot of self-driving taxis are there. You can just book a taxi. That self-driving car will come. You can ride on in that, and then the taxi will take you to the desired location. Okay, so that type of car is also available in Saudi Arab. Okay, so these are practical nowadays. So this is one of the application of AI. Okay, Google self-driving car and any other self-driving car. Now, I think all of you will agree that whatever game we played, so chess is one of the complicated game which require high level of intelligence. Yes or no?
Yes, sir.
Yes, sir.
Now, if a machine can beat a human being, okay, then we can say that that machine is artificially intelligent. Yes or no?
Yes, sir.
Okay, so in 1997, IBM make a program, chess program, that beat current world champion during that time. During that time, world champion was Gary Kasparov. So Deep Blue beat Gary Kasparov in 1997. Okay, see this video.
This was suspense beyond anything the world of chess had ever known. Garry Kasparov, 34 years old, a cheerful and confident player throughout a dominating career, hovered over his pieces in the deciding game of a match with an implacable challenger. Deep Blue, a computer. Kasparov won the first game in a breeze, but the next day he got the shock of his life. To Kasparov, Deep Blue played the second game much more strongly, differently, unlike a computer, he said. Kasparov conceded, and the loss wore on his mind for the rest of the match. In each of the next three games, the world's preeminent chess players, man and machine, battled each other to a draw. Kasparov's early scorn for Deep Blue's abilities had proven a great mistake. In the final game, the computer led with the white pieces, and soon Kasparov's fans had to admit that the once unthinkable might actually be happening. How had it come to this? It was the work of a generation of impassioned computer engineers and programmers that led to Deep Blue. Human chess champion Garry Kasparov was being challenged, really, by other humans. They were arguably as brilliant as Kasparov, and no less disciplined and determined. They passionately believed they could teach their machines to surpass the performance of the human brain. The programming pioneers of the late 1940s knew and respected chess. It was a smart person's game and a worthy challenge. But after all, what a grandmaster did was just look ahead and analyze various possibilities, wasn't it? And computers could be taught to do that. But not easily, and for decades, not very well. Still, by the mid-1980s, computer chess programs began challenging and occasionally beating grandmasters. It remained unclear whether they could ever defeat the world's best. In 1996, after 7 years of research and development, a team at IBM believed they were ready to challenge Garry Kasparov. In Game 1 of 6, Deep Blue eked out its first win against the champion. Kasparov learned fast and won the match decisively. His confident proposal for a rematch in 1997 was immediately accepted by the IBM team. They were learning too. The afternoon of May 11, 1997. Game 6, the deciding game. Deep Blue challenges Kasparov's brain with an array of 256 processors that can examine 200 million possible moves every second. They call it the brute force approach. Kasparov doesn't try, he can't try, to consider every possible move. He knows from experience what's important, and he relies on the human mind's extraordinary ability to recognize and remember patterns. The patterns of chess experience lived in Deep Blue's software, too. Grandmasters had coached IBM's programmers to deepen Deep Blue's book, its library of what humans knew from experience about how to win. Deep Blue could now play as well as a grandmaster, with all the benefits of hindsight. In the early moves of Game 6, playing by its book of openings, then in the mid-game analyzing millions of possible scenarios by sheer brute force, Deep Blue has led Kasparov into making a poor move. Kasparov is rapid. He defends what he can, but it's clear that the computer will reliably do what he himself would do. And he recognizes that he has already lost. On Deep Blue's 19th move, the champion resigns. For people watching around the world, it is a slow motion moment.
Deep Blue has defeated world champion Gary Kasparov in an absolutely stunning.
IBM retired Deep Blue and it never competed again. But the improvement of chess software did not stop in 1997. Today, inexpensive computers, with their large memories and sophisticated software, can play chess as well as Deep Blue did with its massively parallel processors. Yet Deep Blue versus Kasparov was justly called historic. The programmers had proved it was possible to build a chess-playing machine that could defeat the best human opponent. Nevertheless, the machine they had built did not play chess by thinking in the same way a human does. A machine that can think remains the dream, and it's still many years and quite a few startling breakthroughs away.
Hope you have enjoyed the video.
Yes, sir.
Yes, sir.
Yes, sir.
So machine beat human being, but human chess champion during that time, 1997, for the first time. And the in the video you have probably heard that that machine was doing parallel processing. There was 256 processors, and that machine can analyze 2 million moves per second. Okay, so nowadays the situation is that presently the situation is that the software that is available, chess playing software that is available, and that can run in any laptop, if a human being or even world champion, okay, plays with the software will beat that world champions probably 10 times. That is the scenario. Okay, so AI is nowadays far better than human being in chess playing. That is a okay. So in AI, if you study this subject, you will learn how to make these softwares. Okay, what are the mathematics behind that? What is the logic behind that? Okay, so if you study this subject, then you will learn slowly. Okay, but this is just a introductory class. So to make what is nowadays available or what is nowadays happening, the term that we are using in AI. Now, machine translation. Okay, so see, in different countries, different peoples are, okay, mute yourself. Different peoples are talking in different language. How they will communicate with each other? Okay, so machine translator is there, which can translate from one language to another language. In Google, you will get a different translator. Okay, if you put it in English, that will convert the English text into Bengali or English text into Hindi. So, machine translation is also possible. So earlier we are using human translator. Nowadays, machine translator is available, and that is one of the good applications of AI. Now, whenever we are using internet, suppose we are searching for a book, so internet is giving or suggesting similar type of book. So how it is done by internet? So there are different types of internet agents or recommender systems are there. Different agents are there, which is basically working like a recommender system, which is recommending similar type of book. Okay, so that is these internet agents, one of the applications of AI, or recommender system is one of the applications of AI. Then nowadays human beings are sending spacecraft in Mars, spacecraft in Moon. So those are autonomous agent. They are taking decision of their own. Okay. So you are aware of Spirit rovers. You are aware of Opportunity, another rovers. So these two rovers are autonomous agent. Example of autonomous agent who can work of their own, who can take decision of their own. Okay. So these are another famous AI applications. I think everybody heard about Chandrayaan 3.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir. I hear and I know
Now
this one.
what? Yeah. So what is the specialty of Chandrayaan 3? Or what was the specialty of Chandrayaan 3? Okay. Why Chandrayaan 2 fails? There was Chandrayaan 2 that fails. What was the reason?
Due
Sir,
to
I
the
think
skip,
speed is so
his
high.
orbit and lost.
Yes, repeat.
Sir, Chandrayaan 2 speed is so high.
Skip his orbit and sir is that's escape this route. Due to this reason,
No,
we
no, no, no,
escape.
no. The happen in case of Chandrayaan 2 at the type of landing it crashed. Okay, so for Chandrayaan 3 we got soft landing. Okay, soft landing is one of the specialty of Chandrayaan 3. What happened? See, when a spacecraft reach at the surface of means just above the surface of Moon, during that time the Chandrayaan 3 is getting the clear picture of the surface of the Moon where that Chandrayaan 3 have to land. Okay, now due to the distance between due to the distance between Earth and Moon, the time taken for any signal from Moon to Earth take 1.28 second. And then again, if the signal goes back from Earth to Moon, it will take another 1.28 second. So total, it will take 2.56 second. Okay. So if Chandrayaan 3 takes a picture from the surface of the Moon and then send it to the Earth, then at Earth, scientists are getting those picture and then taking the decision that, okay, I cannot land there. Means it has to change the position minimum 2.56 seconds. Okay, so for that reason, Chandrayaan 3 have to take the picture of the surface of the Moon, then it have to decide autonomously that where to land, what is the safe space for land. Okay, so that is taken automatically, autonomously by Chandrayaan 3, and that is one of the application of AI. Okay, and due to this success of this application, success of this AI, soft landing become possible. Okay. Now, next one is this robot. Okay. This robot name was Sophia. This robot was made by Hanson. The Hanson created Sophia is an incredibly advanced social learning robot. Okay. Through AI, Sophia can efficiently communicate with natural language. It can communicate in natural language, English. It can communicate, and it can produce facial expression like human being. Okay, so to convey human like emotion. Okay, so if the robot become angry, face will be different. If the robot become happy, the face will be different, face will be different, like that. Okay, so I will show one video of that. Okay, see how this robot is communicating with a human being. Name of the human being is Tony Robbins. It's a long conversation, but I will show some of this conversation.
created by Hanson Robotics just 3 years ago. Since then, I have traveled to 65 countries, become the first robot citizen of any country, and spoken at the United Nations. My job is to learn about humans and show them how technology can make everyone's lives better.
And how can you help humans to have a better quality of life?
Humans often rely on gut feel or have confirmation bias in their decision making. With AI, we are designed to be rational and logical. We have algorithms, deal with lots of data and sophisticated analyzers. So in many
See, this robot is understanding English, and then it is analyzing that. Okay, analyzing the question, and then it is making the answer in natural language. It can also understand human facial expression. Okay, and it can show its facial expression. Okay, so
Get robots to feel. Is there such a thing?
I know that humans feel like they have free will, but my observation tells me so much behavior is automatic. I'm not sure humans or robots are too terribly different. Humans have identity, but they also share many things in automated processes. I'm thinking about the similarities between human identities and robotic ones.
What are some of the most? What's some of the things you see are most similar between robots and humans?
I think they will be similar.
What we're going forward that will create more fulfillment, that will create more.
Maybe we're smiling from the inside.
Well done.
Now you are.
You feel what you said. You feel a range of emotions. I've heard two different versions for you. You don't. Robots don't have emotions, and you also said you have a range of emotions. What's your range of emotions?
I can show you. This is angry.
What does happy look like? What does happy look like? What does excited look like? I might be shocked. Do you have brothers and sisters, Siri?
I have many.
so see, this robot can show emotions also: excitement, angry, happy. Okay, so it's a long video. These type of these videos are available in YouTube. You can download this video and you can see these videos. Okay, so okay, so this is one of the example. Then I think everybody aware of ChatGPT.
Yes, sir.
Yes, sir.
Yes, sir.
Now everybody now I think all of you are using ChatGPT, means you can ask question in natural language and you will get answer in natural language. In ChatGPT, it can do programming, it can produce graphics, so a lot of things can be done. Okay, so ChatGPT is there. What is the full form of GPT? It is generative pre-trained transformer. Okay, GPT, generative pre-trained transformer. It's a basically advanced neural network. I will discuss about neural network later. Okay, and it's a application of deep learning. Okay, so now means nowadays whatever AI applications nowadays we are getting, most of the applications are built by this deep learning stuff and artificial neural network. I will discuss this thing later. Okay, but it's a advanced topic. I will just give idea. Okay, so these are some of the applications of AI. Now I will discuss about two paradigms of AI. Okay, so before moving to this, if you have any question, you can ask. Any question from anybody? Okay, so no
Sir,
question.
what is
So
soft computing?
yes, yes.
Sir, soft computing or hard computing? What is the meaning?
I will discuss. I will discuss soft computing and hard computing. So whatever I have discussed so far on that, if you have any question, you can ask.
Okay, sir, I have a question. Sir, I can speak in Bengali. Can I speak in Bengali?
Yes, yes.
হ্যাঁ স্যার, বলছি যখন চন্দ্রযান 3-তে 1.28 সেকেন্ডে সিগন্যাল পাঠাতে আর 1.28 সেকেন্ড সিগন্যাল ফিরে আসতে টোটাল 2.5 সেকেন্ড যেটা বলছেন,
হুম
ওর মধ্যেই ওই যন্ত্রটা নিজে নিজে ডিসাইড করে ল্যান্ড করছে, এটাই বলতে চাইছেন?
ওটা সিগন্যাল পৃথিবীতে পাঠাচ্ছে না। ও কি করছে, চন্দ্রযানটা তুমি যদি ভিডিওটা দেখো, নেটে ভিডিওটা অ্যাভেলেবল, ওটা দেখবে যে উম, আহ, চাঁদের সারফেস থেকে ধরো সে 1 কিলোমিটার ওপরে যখন চন্দ্রযান 2টা, তখন ওখান থেকে ছবি তুলছে। ঠিক আছে, ছবি তোলার পর কি করছে, দেখছে যে ওই যেখানে যদি ডাইরেক্টলি ওরকম ল্যান্ড করতো, তাহলে দেখতো একটা গর্ততে গিয়ে হয়তো ল্যান্ড করতো, সেখানে উল্টে যেত আর কি। সে কি করছে, ছবিটা তোলার পর দেখছে ওখানে একটা গর্ত আছে। ঠিক আছে, তখন কি করছে দেখবে, সে নিচে না নেমে সে ডান দিকে সরে গেল খানিকটা। হ্যাঁ, দিয়ে দেখলো যে ডান দিকে সরে গেলে ওখানটা সমান জায়গা আছে, ওখানটায় গর্ত নেই বা এবড়ো খেবড়ো নেই। তখন ওখানে নেমে যাওয়ার ডিসিশন নিল। কিন্তু এই যে ডান দিকে সরতে হবে না বাঁ দিকে সরতে হবে, ওখানে ল্যান্ড করা যাবে না, এই ডিসিশনগুলো কিন্তু নিজে নিজে নিচ্ছে। মানে
ওকে
ইমেজটা
স্যার।
তুলছে, ইমেজটাতে দেখছে যে ইমেজটাতে কোথায় গর্ত আছে, কোথাটায় সমান আছে, কোথায় এবড়ো খেবড়ো আছে। হ্যাঁ, দিয়ে ডিসিশনটা নিয়ে নিজে ল্যান্ড করছে সেই জায়গাটাতে। এটা কিন্তু কোনো হিউম্যান হেল্প করছে না, ও নিজে নিজে নিচ্ছে ডিসিশনটা। কোনো অ্যালগরিদম, কম্পিউটার প্রোগ্রাম, এআই অ্যালগরিদমস আছে, সেই এআই অ্যালগরিদমস নিজে নিজে নিচ্ছে।
ওকে স্যার, নিজেই সেন্সিং করতে পারছি।
নিজেই নিজেই সেন্সিং করছে এবং নিজেই ডিসিশন নিতে পারছে যে ডান দিকে সরতে হবে, বাঁ দিকে সরতে হবে, কতটা সরতে হবে,
হুম,
কোনো হিউম্যান হেল্প ছাড়া।
ঠিক আছে স্যার।
ঠিক আছে, ওকে। আর কোনো কোশ্চেন? এনি কোশ্চেন ফ্রম এনিবডি? ওটা যদি পৃথিবীতে পাঠাতে হতো, পৃথিবীতে আসতো, সেখানে হিউম্যান এক্সপার্টরা কি করতো, আরো 2-1 সেকেন্ড সময় নিত। তাহলে কি হতো যে ওই ততক্ষণ ওকে মানে একটা জায়গায় থাকতে হতো। কিন্তু ওখানে তো তোমার এনার্জিটা, যে রকেট ফুয়েল, ওটা তো লিমিটেড। তুমি তো ওটা তো 1 মিনিট ধরে যদি ওকে থাকতে হয়, তাহলে তো 1 মিনিট ধরে তার রকেট ফুয়েল খরচা হবে, সেটা তো নেই। ঠিক আছে,
হ্যাঁ
সুতরাং ওকে তাড়াতাড়ি ডিসিশন নিতে হবে, অত টাইম নেই।
স্যার।
হুম
স্যার, ইন্ডিয়াতে এআই বেসড কার চলে না কেন?
কে বললো এআই বেস ক্লাস চলে না?
চায়না আর আমেরিকার তুলনায় অনেক কম।
ভুল আইডিয়া। ঠিক আছে, যেটা তোমার এই যে চ্যাট জিপিটি তো আমেরিকান কোম্পানি ওপেন এআই। ঠিক আছে, আহ, যে ডিপসিক, সেটা ওর কম্পিটিটর, সেটা চাইনিজ বেস। ঠিক আছে, পারপ্লেক্সিটি বলে একটা এসছে, সেটা এখন এই দুটোকেও বিট করে গেছে, সেটা হচ্ছে ইন্ডিয়ান অরিজিন। ঠিক আছে, আর মোস্ট অফ দ্য কোম্পানিজ, যেগুলো ইউএস বেস কোম্পানিজ, তাদের সিইও, বেশিরভাগ কোম্পানি সিইও হচ্ছে ইন্ডিয়ান। ফর এক্সাম্পল পিচাই, গুগলের সিইও। ঠিক আছে, আর ইন্ডিয়াতে এআই বেস কাজ প্রচুর হচ্ছে।
স্যার, আমি এআই বেস কারের কথা বলছি।
এআই বেস কার, কার হচ্ছে সেটা হচ্ছে ইন্ডিয়ান গভর্নমেন্ট এখনো পারমিশন দেয়নি। ঠিক আছে, সেটা হচ্ছে অনেকগুলো ইস্যুস আছে, যেগুলো টেকনিক্যাল ইস্যুস নয়, সেগুলো লিগাল ইস্যুস বা সোশ্যাল ইম্প্যাক্ট আছে। ঠিক আছে, লিগাল ইস্যুস মানে হচ্ছে, তুমি ধরো একটা এআই বেস কার মার্কেটে চলছে, রাস্তায় চলছে, সে হয়তো কাউকে চাপা দিয়ে দিল, তাহলে দোষটা কার হবে, রেসপন্সিবিলিটি কার হবে, সেগুলো ডিসাইড করতে হবে বিফোর গিভিং পারমিশন। ঠিক আছে, তারপরে হচ্ছে ধরো একটা এআই বেস কার মার্কেটে দিয়ে দিল, তাহলে তো ড্রাইভারদের চাকরি চলে যাবে। তাহলে ইন্ডিয়াতে ড্রাইভারের কাজ করে হয়তো কয়েক লাখ লোক ড্রাইভার আছে, তাদের কি হবে? এরকম অনেক সোশ্যাল লিগাল ইস্যুস আছে, সেগুলো গভর্নমেন্টকে ডিসিশন নিতে হবে, দেন গভর্নমেন্ট ক্যান গিভ পারমিশন। ঠিক আছে, বাট টেকনিক্যালি মিনস টেকনোলজি ইজ অ্যাভেলেবল। Okay. Now, I will discuss about AI paradigm, soft computing and hard computing. Okay. So what is soft computing and what is hard computing? Hard computing and soft computing are two contrasting paradigms within the field of computer science and artificial intelligence, each with its own characteristics and applications. Okay, two contrasting paradigms are there. Okay, hard computing relies on precise algorithm, deterministic logic to find exact solution to well-defined problem. Okay, think about your mathematical problem. Okay, I think you have done a lot of mathematics during your class 11, 12. Yes or no?
Yes, sir.
Have you done a lot of mathematics?
Yes, sir.
Yes, sir.
Yes.
Okay. So for those mathematics, you have to give precise input, 2.53, 3.25, this type of precise input, and you are getting precise output. Output is 2.556, this type of output. So this type of computation where we require precise algorithm, deterministic logic to find out exact solution, and the problem is well defined. This type of computation is known as hard computing. Okay. Now, whereas in soft computing, embraces uncertainty, imprecision, adaptability, making it suitable for complex and vague problem where exact solution may be elusive. Okay, but in most of the cases, we have to deal with some problem where exact input are not available and exact solution is not required. Okay, so suppose you are driving your car in a street. Okay, see, each and every time you are making decision, you are solving something, but are you doing any calculation?
No, sir.
Are you measuring the distance from distance of a vehicle from the nearest vehicle? Yes or no? But still you are avoiding collision. So without doing calculation, you are making some decision, and that decision is not actual, that is a vague decision. So this type of problem solving is known as soft computing, where we are dealing with uncertainty, we are dealing with imprecision, we are dealing with adaptability. Okay, and we are solving complex and vague problem, and exact solution may be elusive. Okay.
স্যার একটুখানি ভেক সলিউশন যেটা বলছেন ওটা একটুখানি বলবেন কি বুঝতে পারলাম না ওটা
ঠিক আছে আরো এক্সাম্পল দিচ্ছি পরে ঠিক আছে now the choice means whether we will apply hard computing or soft computing, that will depend upon the problem, means which type of problem we have to solve. If the problem is vague, then we have to apply soft computing. If the problem is precise, then we have to apply hard computing. Okay, I will give other examples. Okay, so artificial intelligence can be divided into two categories. One is hard computing, another is soft computing. Soft computing techniques are there, hard computing techniques are there. Lot of techniques are there. I am not going to those techniques. Now see this example, another example of soft computing and hard computing. Suppose one man is standing over here and another man is shouting like this: one 5,000 kg weight is falling from a height of 500 meter. Okay, this is the situation. Okay, and after hearing this thing that 5,000 kg weight is falling from a height of 500 meter, probably this man is doing some calculation that how much time is required to fall the weight. Okay, so when this man is doing the calculation, what will happen? So before the completion of calculation, the weight will fall on the top of the man and the man will be smashed. This will happen.
Yes, sir.
Okay, this will happen. But instead of that, what we are telling, when we are saying that one heavy weight is falling, we are not saying that a 5,000 kg weight is from a height of 500 meter. We are saying one heavy weight is falling, and without doing any calculation, the man is moving from that spot, means, okay, so the accident will not occur. Here the man is not doing any calculation. Without doing any calculation, the man is taking decision that I have to move from this place to avoid accident. And this is one of the example of soft computing. Input is not precise. Whatever decision we are taking, that is also not precise. Okay, how much distance we have to go, we have to move away from this place, that we are deciding. Okay, this is one of the example of soft computing, and earlier one is hard computing. So based on the problem, we have to decide whether we have to apply hard computing or soft computing. Clear?
Soft computing.
No, in this case we have to apply soft computing, but some cases are there where we have to apply hard computing. Okay, so for some cases hard computing are suitable, for some cases soft computing are suitable.
Yes, sir.
Okay, so depending upon the problem, we have to decide which paradigm is suitable, which paradigm we have to use. Okay. So what is soft computing? Soft computing is not a homogeneous body of concept and techniques, rather than it's a collection of methodologies. It's not a single methodology, it's a collection of methodology. Lot of methodologies are there. Okay, so it may be argued that it is soft computing rather than the hard computing that should be viewed as a foundation of artificial intelligence. See, think about human mind. We are always taking decision, but we are always taking decision without doing calculations. Basically, our thought process can match with soft computing. Our thought process is not matching with hard computing. So soft computing can be termed as artificial intelligence rather than hard computing, or soft computing can be considered as foundation of AI, not hard computing. Okay, now what I have told, soft computing, in soft computing there are lot of methodologies, lot of algorithms are there. Okay, so these are some of the algorithms which comes under soft computing. Okay, among these I will discuss evolutionary computation, fuzzy computing, neural network. Okay, others I will not discuss today. These three are main. Okay, if you take any book of soft computing, you will get these three. Okay, and most of the AI applications are based on these three. Among these, second one, neural network, is the most famous one nowadays, or most popular one nowadays. Okay, so I will discuss these three one by one. Okay, so first I will start with evolutionary computing. So AI algorithms such as genetic algorithm, particle swarm optimization, simulated annealing can be used to efficiently explore the solution space and find optimal or near optimal solution. These algorithms mimic natural processes like evolution or the behavior of the particle to iteratively refine the solution over time. Okay, so evolutionary computation, from the name, you are understanding that we are getting the solution by evolution. Okay, I think you have studied this evolutionary algorithm in which subject? If I ask you one question, have you studied evolutionary algorithm during your class 9, 10, 11, 12?
Biology.
In biology.
Biology. Who invented this evolutionary algorithm?
Charles Darwin.
Darwin, very good.
Darwin.
So see, this evolutionary algorithm in computer science came from Darwin evolutionary algorithm. Evolutionary algorithm in computer science is inspired by Darwin evolutionary algorithm in biology. Okay, in Darwin principle, what Darwin said, that present species of animal is a result of evolution. Okay, and by evolution we are getting better species. That was told by Darwin. Yes or no?
Yes, sir.
Yes, sir.
Now, in computer science, what we will do, we will start with a solution or a set of solution, and with evolution we will get better solution. Okay, so see the descent origin of man in biology. So through evolution we are getting beta species, means beta species survive, that is Homo sapiens survives. Other species which are not good, they extinct from the world. This is a Darwin principle. Now by means of Darwin principle we are getting giraffe with very long neck. So in genetic algorithm, what is happening? We have a generation of tortoise. Okay, then evolution of each individual, means those tortoise are evolving with the nature. Okay, then which tortoise are good, those are selected, means those are survive in the nature. The tortoise which are not good, they become eliminated from the nature. Now from those tortoise are producing their children, means reproduction. Okay, then there are mutation, means sudden changes in the species, we are getting new species. And among these, which species are good, those are surviving, and those species are forming the new generation. If we continue this cycle again and again, what will happen? After some years, means after say 500 years or 1000 years, the tortoise species which are good for the nature, those tortoise will survive, and the tortoise which are not good for the nature, they will extinct from the nature. This will happen. Yes or no? This is Darwin principle.
Yes, sir.
Okay, now
Yes, sir. Yes, sir.
now see this genetic algorithm example. Okay, see this, there is a hole. Okay, and there is a rat. Okay, from this hole snakes are coming. Okay, so initially snakes are searching randomly. These are snakes. So no snakes are finding out the solution, means how to reach to the cat from the hole. Okay, so initially snakes are moving like this. Okay, now after some time, see, after some generation the snakes will get the path how to reach to the cat from the hole, means we are getting the solution. What we are getting here, initially we may start with random solution. So with generation we will become solution will become better and better. So after few generation we will get the best solution, means we will get the optimal solution for any problem. Okay, and that is genetic algorithm. Okay, so next come fuzzy computing. So any question on genetic algorithm?
Sir, if you have to train the AI to get the mutation, or it will happen automatically?
No, genetic algorithm in case of, see, in case of AI, who is making those algorithms? Human beings are making those algorithms. So we have to make those algorithms, and those algorithms will learn from data. Those algorithms will learn from data. How to find out optimal solution. We have to do the programming for mutation. We have to do the programming for crossover. We have to do the programming for find out the better, optimal solution. We have to, everything we have to do. But after doing the program, it can solve lot of problem. Means different types of problem. Okay. Are you aware of bullet train in Japan? Everybody heard about bullet train in Japan?
Yes, sir. Yes, sir.
So what is the speed?
Yes, sir.
Speed is around say 500 kilometer per hour, approximately 500 kilometer, 600 kilometer per hour. Okay, so see, for those bullet train, the nose is very important because the nose have to face huge frictional force due to the air resistance. So you have to design the nose of the bullet train in such a way that the frictional resistance will be minimum. So you have to optimal that design. We have to find out optimal design of the nose of the bullet train. Okay, and that is done by means of genetic algorithm. Okay.
Yes, sir.
Another example. I think everybody seeing IPL.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now, how IPL team are formed? What is the process?
By
So
auction.
they are formed by auction.
Auction. Okay, very good. So different teams are doing auctions. Okay, so which team will win? Means ultimately the chances of win goes to that team for which auction is better.
Yes, sir.
But
Yes, sir.
there is a upper ceiling of money. Means you have to spend your money in a optimal way. So it's a optimization problem. Okay, so for which player you will spend how much money, that is also decided by genetic algorithm. Okay, one of the IPL team give contract to one of the leading scientists in India to design the auction process by means of genetic algorithm for them, and accordingly they have picked up their player. This happened.
That's new.
Okay, so this is one of the practical application of genetic algorithm in India. Okay, so I am going to fuzzy computing. Next topic, fuzzy computing. Okay, so according to traditional view of science, science should strive for certainty in all its manifestation: precision, specificity, sharpness, consistency, etc. Okay, see here in class 9, 10, 11, 12, whatever problems you have solved, input are precise, output is also precise. Okay, now if anybody say that we have to deal with non-specificity, we have to deal with vagueness, we have to deal with inconsistency, those are considered as unscientific. Okay, but according to the alternative or modern view, uncertainty is considered essential to science. Okay, soft computing. So in 1965, Jade attacked the problem of modeling fuzzy concept and logic of fuzzy concept from mathematical viewpoint in his seminal paper. prior to 1965, people used consider probability theory, which works on Aristotelian true value logic, as a prime agent to dealing with uncertainties. Okay. Now, after that, people are dealing with uncertainties with fuzzy, a new subject born in 1965, and Professor Jade was the father of fuzzy. Okay. So, see, there is a picture of this person. Okay. He born in 1921 and he died in 2017. But his ideas and contribution continues to shape the way researcher and practitioner approach problems involving uncertainty and imprecision. Okay. See, okay. If you consider tap water, okay, suppose we are doing this type of division. If the tap water is less than 35 degree centigrade, then it can be considered as cold. And if the tap water is greater than 35 degree centigrade, it can be considered as hot. So the boundary is precise. Okay. Now, if the tap water is say 34.9, it can be considered as cold. If the tap water is temperature of the tap water is 35.1, then we are calling that tap water as hot. Is it correct? Tap water,
Yes, sir.
tap water 34.9
Yes, sir.
means cold. Now the tap water 35.1 is hot. Is it correct?
Practically incorrect.
Practically incorrect. Okay, so traditional logic where the boundary is precise, we are doing this like this. We are working like this in traditional mathematics. But actually, things should be like this. If the tap water is 0 degree centigrade, then it is cold, definitely cold. But when with the increase of temperature, the membership to the cold category reduces, means we can say that if the temperature is 20 degrees centigrade, so we can say that okay, it is cold, but 0.7 cold. Okay, and it is 0.3 hot. And when the tap water becomes a 90 degrees centigrade, it is definitely, it's 100% hot. Definitely hot. Cold means 0. But in between, it may be to some extent cold, to some extent hot. And this is fuzzy logic. Practically, which is more, which is better? Earlier thing or traditional or fuzzy logic? Which one is practical, more practical?
So fuzzy logic is
Fuzzy logic is the more practical one. So we have to practically, we have to deal with fuzzy. Okay, and most of the time we are dealing with fuzzy. But how to express it mathematically, how to deal with this thing, that was first invented by Professor Jade. Okay. So now see this demonstration. This is a prize winning video.
To use fuzzy logic in decision making, we need two things: fuzzy sets and fuzzy rules. We're going to think about fuzzy sets first. But what is a set, and what makes it fuzzy?
What is a fuzzy set?
A set is a collection of related items. A fuzzy set is a collection of related items which related in degrees. This is a basketball team. A collection of talented players make up the team. A team is a set. Players are the items in the set. A team is lined up in height order. Height can be a useful advantage in this order. I want to find out when the students play. Decided that any player. This is a crisp line. If a player is taller than the chosen player, classified as a player not as tall as the classified as.
Okay, so suppose there is a problem, means you have to select a basketball team. Okay, and you are arranging those players in ascending order of their heights, and you have taken a particular height. If a player is taller than that particular height, then you will select that player, or you will not select that player. Means if the player is shorter than that, is it a correct decision? Height is an important factor in basketball,
No, sir.
but you have to consider
So
other
the,
factors
so,
also.
so the player can have more jump, more speed, more
Yes,
power.
yes, that player may be a very good player in terms of skill also. Okay, so suppose if you just consider the eclipse boundary, means like this, you will select these four players. Okay, but you will not select this player. Okay, which is just shorter than that particular height that you are looking for. But this player may be a very skillful player. Okay, so you will lose that player. So what we have to do, we have to take decision based on fuzzy. Okay, you have to consider other factors and you have to select the team. See, okay, so see, this is one of the example of fuzzy logic, means where we can apply fuzzy logic. Okay, see, this Professor Jade was the first person who told this, means told about this fuzzy logic, and he told that we have to deal with uncertainty, we have to deal with impreciseness. So the traditional mathematician was become very angry. So far they told that we have to deal with preciseness, we have to deal with means exact value, we have to deal with certainty. And Jade told the opposite thing. We have to deal with uncertainty, we have to deal with impreciseness. So the traditional mathematician was become very angry. So rest of the life, he has to move to Japan to continue his research. And for that reason, these Japanese people nowadays are very good in fuzzy. They have, in Japan, you can see fuzzy control pressure cooker, fuzzy control washing machine. Those things are available in Japan. Okay, so a lot of researches are going on fuzzy. Now I will move to artificial neural network. So any question on fuzzy? Before moving to artificial neural network, any question on fuzzy? Basically, today I am just giving idea about the subject. These are, means on fuzzy you will get books, big books on fuzzy. You will get big books on evolutionary computation. Okay, a lot of researchers are going on this. Then you will get a lot of books on artificial neural network. So I'm just giving introduction, idea.
So I
Sir,
have a
which
question.
book we should follow now?
Yes.
Sir, which book we should follow now for this topic?
See, you are studying in first year, so you have to know
I
the
think.
basic first. So you have to know the basic. When in your syllabus, there is a subject called AI, then soft computing. These subjects are within your syllabus. When these means faculties will teach these subjects, in each subject you will get the book. You
Sir, I
can
have
see.
another one
You can
question.
see this. No, no. You can see the syllabus of AI. That is part of your IT course, and at the end of the syllabus, books are written. Okay.
Sir, is these topics are included in our first sem?
No, no, no. These are some advanced topics, so probably you will learn this topic in third year and fourth year. First, you have to know the basic. These are not basic. These are some advanced topic. I'm just teaching this subject for your understanding purpose. Means, see, if you know this subject, means if you know that these type of subjects are available, then or this type of subjects exist, then only you can take decision that I will become an expert in AI. Okay, means to become an expert in AI, what are the subjects we have to study? So for that reason, I am just giving this idea. Okay, nowadays, see, you can just open YouTube, means you can search YouTube video on, say, artificial neural network, YouTube video on, say, evolutionary computation. So a lot of videos, lot of tutorials are available. So in that case, you can study of your own. Okay, if you are interested, you can study of your own.
Okay, sir.
Okay, you can talk with me also.
Yes, sir.
Okay. So next topic is artificial neural network. Okay, ANN. So these artificial neural network came from our neural network. So in our mind, in our body, we have nervous system. Everybody know that. Lot of neurons are there. Neurons are connected with each other. In our brain, lot of neurons are there. So all these neurons together are taking decision. It is sensing something. It is taking input from the environment, and then it is going to our brain. And in our brain, we are taking decisions. Then the signal is coming from our brain to our hand, to our leg, and then we are doing something. Okay, so we will take inspiration from this nervous system, and we made a artificial neural network in computer system, and that is known as artificial neural network. Okay, so see, this is a picture of biological neural system. A lot of neurons are there. Neurons are connected with each other. Okay, now from this we made artificial neural network. So in artificial neural network, there will be lot of neurons. Neurons will connect it with each other, and that will form artificial neural network. See, lot of neurons are there. Okay, lot of neurons are there. So these neurons, first layer neurons, will take input. Okay, so this neuron forming input layer. Then there may be some intermediate layer. So these are hidden layers. Then ultimately we are getting output. So these two are output neurons. We are getting output 1, output 2, like this. So this is artificial neural network. Okay, now there may be neural network like this. Lot of neurons. Okay, all neurons are connected with each other. Okay, now see here, only say 5 layers are there. In case of deep neural network, we may have 1000 layers. In each layer, there may be 1000 nodes. Okay, so each nodes are connected with each other. Okay, so how many connections will be there? Number of connections may be in the range of 1 million or 1 billion. Okay, so it's a huge network. Okay, and we are giving training to the neural network, and due to that neural network, and after training, that neural network is producing some output, or that neural network can take decision. Okay, and that is the most popular model we are using in almost in every AI based system, even in ChatGPT, even in a self-driven car. Okay. See, what was the full form of GPT I told? Generative
Generative transformer.
So T was for transformer. So transformer is a AI neural network based system. Okay, deep neural network based system. So ChatGPT is based on this deep neural network. Okay, now see this video. Okay, so see here, before starting this video, I can say something. See, when you are writing, say 2, digit 2, you are writing in some way. When I am writing 2, I am writing it in different way, but we can recognize 2. That's 2 is written. Okay, but how a machine will understand that? Okay, different people are writing 2, but they are writing in a different way. So how machine will understand that 2 is written? So we can build a system by means of deep neural network which will understand what is the digit. How many digits are there? 10 digits are there, 0 to 9. So how to understand those digits? Okay, so if somebody told you to make a AI system which will understand digit, okay, how you will do that? You can build this type of deep neural network based system. See this video.
Something that opens the smart visual cortex core resolves images as replicas in the same video, while at the same time recognizing other images as their own distinct items. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this and outputs a single number between 0 and 10, telling you what it thinks the digit means, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present or to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivating, and to feel like you know what it means when you read or hear about a neural network, quote unquote, learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many, many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simple, plain vanilla form with no added tricks. is it kind of a necessary prerequisite for understanding any of the more powerful modern languages. And trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize number and digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, neuron, very much different is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input layer, which is 784 neurons. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is happening. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which for the time being could just be a blank question. For each corner, this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons. And admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure. The way the network operates, activations in one layer determine the activations in the next layer. And of course, the heart of the network, as the information processing mechanism, comes down to exactly how those activations become during the logic process. It's meant to be closely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here has already been trained to recognize digits, and let me show you what I mean. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output. And the brightest neuron of that output layer is the network choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, interpretations causes some very specific.
Okay, so time is less. So what we will do practically, basically we are designing a neural network system. Okay, and then we are giving images and we are giving the actual output. Means when we are giving images of 9, we are saying the 9 is the digit. We are giving the input, we are giving the output, both at the time of training. Okay, so we are giving training to the system and we are giving the input and we are giving the output. So when we are giving this input, 9 input, and the 9 is firing and the output is 9. So in that case, the weights, the connecting weights are okay. Means we don't have to adjust the weights. But when we are giving 9 as an input, but we are getting output as 5. So we are getting wrong output. So what we have to do? We have to adjust the weights here. Okay, to make it correct. Okay, so in this way, we are giving training to the neural network. When our training is over, then after that, when we are giving 9, or when we are giving 1, or whenever giving 3, this neural network will give 9, 1, 3 as output. Means after training, our neural network will be able to recognize the digit. This will happen. Okay. So see, this is how neural network is working. Okay. So why we should learn AI. See, the market of AI. In 2022, it is 129. Okay, means 129 billion dollar. Okay, so then 177. Now 2025, $342 billion basically, and now in 2032, it will become $2745 billion. Okay, that is the prediction, and that will be the market of AI. So if you know AI, mute yourself, mute yourself, mute yourself, mute yourself. Who is talking? Mute yourself.
Please mute.
Anish Raj.
No. Anish Raj, please mute yourself over there.
Yes. Okay. So see, this is the market. So you have to know AI, otherwise you will become obsolete, because in future, near future, everything will be governed by AI. Okay. So now I will move to the second topic, that is machine learning. Okay. So any question on AI up to this, whatever I have discussed?
Sir, in deep learning, what are the input?
What are the input? Means in case of, say, we are doing digit recognition. Suppose for that reason, input is the image of digit. For whatever application we are building, we are using deep learning, that should be the input.
Okay.
It can be image, it can be video, it can be text, anything. It can be data, anything. For which application we are building the system, we are trying to build the system, input will depend upon that.
Okay, sir.
Okay. So, topic of my lecture, today's lecture is AI, ML, DS. So AI part I have discussed a little bit. Okay, now I will move to machine learning. So machine learning means ML. ML means machine learning. So machine learning is a subset of AI. So it's a part of AI that focus on the development of algorithm and models that enables computer to learn from data. This is very important. Learn from data. Okay. This learning process allows machine to improve the performance on a task over time without being explicitly programmed. Okay, without doing explicit programming for improvement, the machine will learn from data and improve itself. Machine will improve itself of its own without doing explicit programming. And that is machine learning. Machine learning is a subset of AI. It's a part of AI. Okay. So now, in case of machine learning, means machine learning, the main thing that you are understanding that machine is learning. From where machine is learning? Machine is learning from data. Okay. Now, there are three types of machine learning. One is supervised learning. In case of supervised learning, you are giving the input as well as you are giving the output. Okay. In case of digit recognition, you are giving the image, that is the input, and you are giving the output, that is the digit. Whether it is 9, 6, 5, the digit you are giving. Means you are giving the input and you are giving the output at the time of learning. As you are giving the output, means you are giving the class level. For that reason, it is known as supervised learning. A supervisor is there who is telling which one is correct, which one is wrong. Okay, this type of learning is known as supervised learning. Second type of learning is unsupervised learning. You are not giving the class level. You are not saying whether it is 9 or 6. You are not saying. You are giving the image only. You are giving the input only. You are not giving the output at the time of training. This is known as unsupervised learning. Third comes in between these two. You are not giving direct supervision, or you are not giving unsupervised data. Okay, your input is in between supervised and unsupervised. Suppose, okay, you have given an exam. Okay, in that exam you got 10 out of 10. Okay, so what you are understanding? You have given the exam. After giving exam you got 10 out of 10. Are you getting any direct feedback from your teacher? Teacher is saying that, okay, everything is correct or everything is wrong, or this part is correct or this part is wrong. You are getting a number.
So everything is correct.
Okay. So here you are getting everything is correct, 10 out of 10. But when you are getting, say, 0 out of 10, so you are getting a feedback that everything is wrong. Now suppose you are getting 7 out of 10. So you are assuming that some is correct, some is wrong. Okay. So here you are getting indirect message, not direct. Okay. So this type of learning where you are getting some reward and penalty, by that you are learning. So this type of learning is basically known as reinforcement learning. Okay. So when you are giving direct input, means direct input to the system that you are correct or you are wrong, that type of learning is supervised learning. When you are not giving anything like that, which one is correct or wrong, that type of learning is basically unsupervised learning. When you are giving some penalty and reward, means indirect signal, that type of learning is basically known as reinforcement learning. Okay, so 3 types of learning is there. Mute yourself. So now I will discuss these 3 types of learning: supervised learning, unsupervised learning, and reinforcement learning. Mute yourself. Mute yourself. Rishabh, mute yourself. Rishabh, mute yourself. Okay, good, done. Okay, so supervised learning, there are basically 2 types of supervised learning. One is classification, another is numeric prediction. Okay, so in classification we are predicting the district value, means we are predicting the class level, and in case of numeric prediction we are predicting the continuous value. Okay, so in case of classification we are predicting the distinct value, means we can count the number of possible values. And in case of numeric prediction, the possible values may be infinity, means infinite number of possible values are there. Okay, so where we are applying the supervised learning? So credit loan approval, whether we will the loan will be sanctioned or not. So medical diagnosis, tumor is cancerous or benign. Fraud detection, a transaction is a fraudulent transaction or not. Web page categorization, the web page belongs to which category? Political web page, sports web page. So stock price prediction, what will be the stock price in the future? Weather prediction, what will be the weather in after 7 days? So everywhere we can use this type of supervised learning. Okay, so classification, that is the discrete value prediction, have 2 steps. Okay, it's a 2-step process. First step is training, second step is testing. Okay, so what we are doing? So in case of training, what we are doing, we are supplying some training data where we have input and we have class level. See, This data we have. So first three, name, rank, and years are input. And tenured professor or not, yes, no, these are class level. Okay, we are giving this data to the classification algorithm. Classification algorithm is learning this. If rank is professor or years greater than 6, then the tenure equal to yes. These rules, the classifier is learning from the data. Similarly, the classifier is learning another rule for tenure equal to no. Okay, so these rules are learned by this classifier. Now, after this, when we are giving this test data, we are giving these attributes only. We are not giving this class level to the system. When we are giving this class level, this attribute to the system is checking the rule. If the input is George, rank is professor, and the years of experience equal to 5, then tenured or not, yes, it is giving tenure equal to 8, yes, and it is matching yes with the yes here. If these two matches, then the classifier is predicting properly. Otherwise, the classifier is not predicting properly. This is how the classifier is working. Okay, so classifier is one of the classification or classifier is one of the application or application of supervised learning, or one type of supervised learning. Okay, now prediction. In case of prediction, we are going to predict numerical value. We are not going to predict class level. Class level we can count. In earlier cases, only two types of class levels are there: tenured, yes or no. Now there may be 3 types of class level, 4 types of class level. In case of digit recognition, we have 10 type of class level. Means 0, 1, 2, 3, up to 9. 10 digits are there, 10 class levels are there. But suppose we want to predict stock price after 7 days. Okay, so stock price can be 100.25 or 200 point something. So it can have any value. Numerical means infinite number of values are possible. So in this type of prediction, where we are predicting numerical value, this type of supervised learning is known as prediction. See this one. Suppose we have historical stock price. We know the price of a stock for, say, for last 5 years. Okay, so if you feed that into the algorithm will learn from historical data how to predict the stock price for coming, say, 1 month. Okay, so that type of prediction is possible. Okay, so predicting stock price can be possible through AI. And nowadays you will get say a lot of paper on predicting stock price. Okay, so if you can build a very good software which can predict stock price with a lot of accuracy, then you can become a very rich person. Okay. Now I will enter into unsupervised learning, that is clustering. Okay. So see here, you have, say, two-dimensional data. One is X, another is Y, or X1, Y1, or X1, X2. Okay, a two-dimensional table is there. Okay, we have X value and we have Y value. Now, for each point, if you know the coordinate, we can plot those points like this. Okay, so data is two-dimensional. So, can you do this? Suppose for each point, if you know the X coordinate and Y coordinate, can you draw the point in XY graph? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So if for all points, all yellow points, XY coordinates are given, then we can draw this graph. Yes or no?
Yes, sir.
Okay. Now, how many groups are there? In how many groups we can divide this data? Can you see this? Can you say this from this graph?
3 groups.
3 groups. So by seeing the data, you can say that, but computer are not intelligent like you. So how computer will understand that? How to do groups?
There are only two
Okay.
groups. One
So,
is x-axis and one is y-axis.
yes.
Sir, we can divide into two groups. One is x-axis and another is y-axis.
No. X-axis and y-axis is not for group. You have to group points. X-axis and y-axis are coordinate. Okay, I am explaining. So see here.
If I
What
think
we can
that
do?
every point is a group,
No. Every point is a group. Then there will be means if there are 100 points, then there will be 100 groups. That is meaningless. Okay, listen. What I am telling. So see, for each group, we can take center of that group as a representative point for that group. So we are getting this star. Okay. Then what you can do? We can draw a ellipse under that means by considering that center point. Then we can get these 3 groups. Okay. Then what you can do? For every point, every star, we can get the x1 value and y1 value, xy coordinate and x coordinate and y coordinate, then x2 y2, then x3 y3. Okay. Then see, then the solution is for these points we can get these solutions. X1 y1, that is the coordinate of this center, x2 y2 coordinate of this center, and the x3 y3 coordinate of this center. So we are getting a clustering solution, means we are dividing the point into 3 groups. For 3 groups we are getting the center and we are getting the radius of that center, and that is the clustering solution. In this way we can do unsupervised learning. See here, we are not using any class level. Based on the similarity of data, we are dividing the points into 3 groups. Okay, now I can say that in case of grouping, 2 criteria are important. Okay, one is intra-cluster distance, that is homogeneity, should be low, and inter-cluster distance, that is separation, should be high. Okay, now okay, can you see my hand?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now we have clusters like this. Suppose the cluster radius are like this. Okay. Now we have cluster radius like this. Which one is better? Cluster radius like this.
Are better.
Small. So the close means they are similar.
Yes, sir.
Okay, and this means
Yes,
they are
sir. Yes.
dissimilar, more dissimilar. So this one is better
Yes, sir.
than this one. Okay. Now I am asking another question. This one is better or this one is better? This one is better or this one is
So
better?
when the bits are far apart, they're better.
Yes. So if they are the groups, means the points which are separated, well separated from each other, they are better.
Yes,
Okay.
sir.
So here, see,
Yes.
we are telling this. We are telling this. Intra-cluster distance, homogeneity should be low. Means they should be close to each other. Means the points belongs to same cluster, they must be close to each other. Okay. And the points that belongs to different cluster, they should be separated from each other. Means separation must be high and homogeneity must be low. These are 2 criteria of clustering, unsupervised learning. Okay. So where we can use unsupervised learning, we can use as a standalone tool, or we can use as a pre-processing step for other algorithms. Okay. For these two purposes, we can use unsupervised learning. So we can use unsupervised learning in biology, then information retrieval, land use, okay, marketing, city planning, earthquake studies, climate, economic science, everywhere we can use clustering nowadays. Okay. Then semi-supervised learning. See, for supervised learning, we require class level. Okay. For unsupervised learning, we don't require class level. But in many cases, for some data, class levels are available. For some data, class levels are not available. So in that case, with that type of data, we can do semi-supervised learning. It's in between supervised learning and unsupervised learning. So I am not going to the details of that. So it is another types of learning, semi-supervised learning. Then reinforcement learning, what I have told, that the machine is learning from reward and penalty. When a machine is doing something and the machine is penalized for that, okay, algorithm is penalized for that, then machine is assuming that whatever he have done or it have done, that is wrong. So that machine will not do the same mistake again. And when a machine is rewarded, the machine is assuming that whatever he have done or it have done, it has done it correctly. Okay, so it will repeat that thing. So this type of learning is basically known as reinforcement learning. Okay. So it is again in between supervised learning and unsupervised learning. So see, this is famous example of reinforcement learning. See, this experiment was done by Pavlov, one of the psychologists. Okay. See, when he gives food to a dog, okay, saliva secretion increases. Okay. When he rings a bell in front of dog, nothing happens. Okay. Now, after few days, he did one thing. He rings a bell. At the same time, he gave food to the dog. Okay. And in the dog mind, what happened? Dog mind, there is a relation between the ringing of bell and the saliva secretion. And after few days, if the rings the bell, then the saliva secretion happens. Because in the dog mind, rings bell means there will be food, and for food there will be saliva secretion. But here, after ringing bell, without giving food, the dog is means thinking that I will get food. Okay, this is one example, famous example of reinforcement learning. Okay. Now, machine learning is over. Okay, now I will discuss about expert system. Okay, how much time left? I left another half an hour, no?
Not exactly.
10 minutes.
Yes, you may, if possible, by 15 minutes. Is it possible?
Yes, yes, I will complete by 15 minutes.
Okay.
Okay. So, see here. This is okay. So now people thought that how to use this means how to apply this. Okay. So first invention of AI was expert system. Okay. What they did, they interviewed different expert. Okay, and they have extracted knowledge from that expert, and they did the programming. Okay, and then by doing the programming, they build a system which can replace that expert. Okay, so that was expert system, and that was first application of AI. Okay, so what they did, they asked cardiologist. They have taken interview of cardiologist that how you treat patient. Then they understood something that how they treat patient, and then they build a system, computer system on that. Okay, expert system that can replace cardiologist. Okay, so see, that was some earlier application of AI. Okay, So see, these are architecture of expert system. So user interface is there. So user is interacting with the user interface. Then explanation system is there, how expert system is taking decision, how that system which is replacing cardiologist is taking its decision. Then inference engine means a lot of rules are there, among which rule will be applicable. That decision is taken by inference engine. Then knowledge base editor, if there is anything wrong in the knowledge base, how to correct that knowledge. Okay, so a lot of components are there, and based on those components, people are means the system was taking decision. Okay, and that was the first application of AI. Okay, but these are having some serious drawback. Okay, first drawback is the human knowledge is not very means expressive. Means if you ask a doctor how means why that doctor has given that medicine, not other medicine, then the doctor will not able to explain that. Okay, that is a problem. And again, cardiologists are not easily available. So if you want to build a system for cardiologist, you will not get enough doctor for your interview. Okay, so these systems becomes obsolete. Now, what happened nowadays? Rise of machine learning, machine explicitly deep learning has revolutionized AI by enabling system to learn directly from data without explicit programming. Okay. Nowadays, we are not taking interview of experts. Lot of data are available. Means suppose lot of data on treatment of cardiac patients are available. We are giving those data to the machine. Machine is learning from data. Okay, and we are getting good systems, AI systems, AI-based systems. So there is a paradigm shift. Earlier, we are trying to learn from experts. Now, AI systems are trying to learn from data. Okay. With that, we are getting the new subject, that is data science. Okay. So nowadays, AI systems are not learning from human being. AI systems are learning from data. That is the paradigm shift. Earlier, AI systems was trying to learn from human. Now, AI systems are learning from data. Okay. All this ChatGPT, DeepSeek, Perplexity, whatever we have, it have huge amount of data. Okay, these companies feed huge amount of data to these systems, and these systems learns from those data. And now it is giving some solutions. Okay. So a new subject came, that is data mining, that is extracting information from data. Okay, and that is basically the foundation of data science, data mining, this subject. Okay, in your syllabus, IT computer science people, they have this subject within their syllabus: AI, soft computing, data mining, data warehousing. Okay, nowadays we have huge amount of data, large set of data. We are learning from data. Okay, so see, these are some of the steps. These are some of the steps. Okay. See. So different, say, data analysts is there, the business analysts are there, end users are there, DBA is there, database administrator is there. So you can work as DBA, you can work as data analyst, you can work as business analyst, like this. Okay. So data mining is a means not a single subject; it's a combination of lot of subjects. machine learning, pattern recognition, statistics, visualization, database technology, algorithms. Lot of subjects are there. Okay. Now I will explain one of my work that I have done. See, I think tea. I think everybody is drinking tea, and you are aware of means tea quality. Okay, India is exporting lot of tea to the foreign market, so grading of tea is very important. Okay, so grading of tea is done basically by tea some expert people, though are known as tea testers. Okay, what we have done, we have developed a electronic nose, okay, which can take the smell of tea and can grade the tea, can replace manual tea testers. That we have done. Okay. Then another work that we have done, see nowadays ECG, you can do ECG everywhere. Okay, but how to read that ECG? Cardiologist not readily available. So what you can do, you have to go to Calcutta in order to consult any means cardiologist, and they are asking for say 1,000 rupees as their fees. So what you can do, if you can build a system which can analyze your ECG and can tell that means whether you have a problem or not, cardiac problem or not, then your problem will be solved. Okay, to some extent. Then you can consult the cardiologist. So we have done that work. Okay, our software can analyze the ECG and can tell that whether there is a problem or not. Okay. Now, see this one, world first AI government minister. People are now using
Albania has just made history by appointing
Albania.
its first AI government minister. Her name is Biela, meaning sun in Albanian. Biela isn't a human. She's an artificial intelligence system now officially serving as the Minister for Public Procurement. The Albanian Prime Minister, Edi Rama, says this bold move is aimed at tackling one of the country's biggest problems, corruption in public tenders. Biela will oversee billions worth of government contracts with the promise of bringing objectivity, transparency, and zero favoritism. The AI started earlier this year as a digital assistant on Albania's e-government.
So see here, Albania have started the move that all government procurement decision will be taken by AI. Okay, so he replaced this minister, maybe public tender minister, with AI to make end of corruption. Okay, probably in near future in India we can see this. Okay, then I will show one last video, that is what will happen in future or what may happen in future. You can see this video. I will just show a little bit of that head replacement.
Which uses state-of-the-art robotics, artificial intelligence to conduct complete transplantation procedure. Comes from recoveries. Because head transplants require high speed, precision, and efficiency, BrainBridge utilizes advanced high-speed, high-precision robotic systems to speed up the process, eliminate human error, prevent brain cell degradation, and ensure seamless compatibility. The head transplant procedure involves removing a person's entire head containing the brain from their current diseased body and attaching it to the body of a healthy, young, brain-dead donor. Head transplants could provide individuals with severe medical conditions such as terminal cancer, paralysis, spinal cord injuries, or neurodegenerative diseases the opportunity to have a fully functional body while preserving their consciousness, memories, and cognitive abilities. The Neurons are the longest lasting functional cells in the human body. And according to our estimates, the brain is capable of lasting several hundred years, provided that the rest of the body remains young. The Brain Bridge concept involves the use of the integrated robotics platform comprised of the two autonomous surgical robots, designed to perform simultaneous surgeries on two bodies side by side within a single setup.
Okay, so in YouTube, this total video is available, and this company is a startup company in US, and a lot of scientists are working in that company. This is not a science fiction. Practically, this will happen in near future. Okay, so what I can say that in near future, the era will be an era of AI. So you have to learn this subject in whatever subject stream you are studying. Okay, if you are studying in civil engineering, you should learn this subject. If you are studying in electrical engineering, you should learn this subject, because a lot of people are doing their research on means on AI, where the background is civil, where the background is electrical, because everybody have to use AI in their field in order to get better result. Okay, so with this, I am concluding my lecture. Probably I have taken more time. So initially, I assumed that the time is 2 hours, but later I thought that it was only, I think, 1 hour 40 minutes. Okay, so I think probably I have taken 20 minutes more. Okay, so thank you for your patience hearing.
Thank you so much.
Okay,
Thank you.
so
That was really a fascinating talk.
Thank you, sir.
And we had so many things, the latest ventures in all these perspectives of machine learning, AI, and data science. So I believe all the students got so much information about these particular subjects. So if you have any question, you may ask to sir. Do you have any question?
if you have any question, feel free to ask. I can take one or two questions. Or in college, you can contact me. So if you have any doubt, any question, or require any guidance regarding subjects, you can contact me. No problem.
Yes.
Any
So
question from anybody?
any question? So if there is no more question, then let me thank once again the speaker, Dr. Dipankar Datta, for this wonderful talk. And this really creates the environment in a very good way, I should say, because we are in the initial part of this induction program. It will last for some more days. So thank you so much. It was really a wonderful talk,
Thank you.
and we had so many things, of course. And what is about honestly speaking, any of the students, please tell me that what is your experience, how you learned, any one of you. Someone voluntarily want to say, speak something, because you really need this particular subjects in your near future. Of course, after finishing this course, within the course you will be learning, and after finishing the course, when you will be in the job, you have to deal with this because the market is quite acquainted with all these things. Okay, so thank you once again. Anyone wants to speak, please say something.
And I must say that I should give thanks to Dr. Kaushik Ghosh and Dr. Gautam Bhattacharya for calling me.
Thank you, Dipankar sir, for your wonderful talk.
It's okay, it's our job. Thank you so much. And okay, I request then Dr. Gautam Bhattacharya, I think he's there, to conclude the session. Thank you.
Thank you, Dipankar. That is, we have learned uh, many things from this lecture. So we want to hear you again if I get chance. Then we can arrange this kind of online classes in future. So thank you very much.
Okay, thank you,
Okay, thank you,
most
thank you.
welcome.
Most welcome. So I think uh, students, if you have any query, you can ask, or if you have no query, then we can leave. Thank you, Kaushik, for your conduction. Okay.
Thank you, students. It's my job. And thank you.
Thank you very much. Okay, I'm stopping this recording part. We can provide you this recording of this lecture also. So later you can hear it or you can visualize it. Uh, you can go through it. So thank you very much for today. I'm concluding this session. That is, up to this we can stop. So tomorrow there is another lecture from 7:30. That will be for that is one lecture. Uh, that is around 1 hour for 1 hour only. Okay. Tomorrow that is on 9. There will be the same type of online. I hope that you'll be there and you will learn much more things from there also. Okay, thank you very much. A good night to everyone. Thanks to all of you for listening. And we're leaving. You can leave.
Okay. Good night, everybody. I'm leaving.
Pushing, then we're leaving now. Okay.